Border Gateway Protocol, BGP. This is one of the widely seen protocol, especially between the ISPs and also between ISP and the enterprises. This protocol has got a very rich metric, and that is called as attribute. We don't call it as metric because it's not simple metric like other routing protocol. For example, OSPF, cost, auto cost based on bandwidth. BGP metrics are not that simple. BGP metrics are not that simple like a hop count in RIP. It is rich metric called attributes. Attributes makes BGP protocol a secured, policy-based routing protocol. A protocol which is secured and policy-based. Security is inbuilt. Unlike other protocols, this uses TCP for forming neighbor. This is not like any other routing protocol. The other routing protocols, they use UDP or IP, multicast, in order to discover neighbor. Whereas BGP don't use any multicast, BGP you do not use any UDP, it uses TCP, connection oriented. The connection oriented approach of BGP makes this protocol a secured protocol. Yeah. Secured. This is secured because of connection oriented approach. TCP based protocol. And this is also having attributes which is contributing to a policy based path selection. See, so far I have just explained 2 points only. This border gateway protocol is a secured protocol. Reason is TCP is used and it is connection oriented. That is how TCPs are secured. So that's the first point. The second point is policy based routing with the help of attributes. So 2 points only so far. BGP uses attribute which helps to do policy-based routing. Which helps in doing policy-based routing. Using the attribute, you can hint, you can give prompt to BGP. See, this word prompting is from AI, artificial intelligence. Prompting is nothing but feeding information, telling what you are expecting. So what you expect from BGP, you feed using the attribute as a prompt. Prompting is done through attribute. BGP uses attribute as a prompt. BGP uses attributes to decide the path. The path selection is based on attributes. So for these two big reasons, this is what a preferred protocol between autonomous system like this. If you see, we got 4 autonomous systems in this picture. At the bottom, what you see is an enterprises autonomous system 65500. Now this enterprises is multi-homed. What is multi-homed? This enterprises is connected to 2 ISPs, A, ISP B, multi-homed. They are multi-homed. Now, between this ISP and the enterprises, we run BGP. Likewise, the customer on the top is also connected to ISP A and B using BGP. So, in short, if I want to say, BGP is used between the autonomous system whenever they are multi-homed. Whenever they are multi-homed. If you notice here, 65500, it is multi-homed. This is one connection, this is another connection. Likewise, this is one connection here, one connection here. Likewise, this ISPA is connected up here and down here. This is called multi-homing. More than one autonomous system connected. ISPA is also multi-homed. It is connected to customer, it is connected to ISPB, it is connected to enterprises down. Enterprises is also another customer. For ISP, enterprises is a customer. For this enterprises, ISP is a transit to reach the customer. See, this is your company, Madhavan & Co. Madhavan has got some customers. The customers are not connected to enterprises Madhavan. They are connected via ISP A and B. Madhavan uses ISP A or ISP B in order to reach the customer. Madhavan has got 2 ISPs. Why? If connection to one ISP goes down, the other ISP acts as a backup. The other ISP will be providing the path to communicate. So if you see customer is also connected to multiple ISPs, so that without any downtime, customer can be reached by the enterprises and vice versa. Not only that, ISP is also connected to many other ISPs and customers and enterprises. So if you take ISPA is also multi-homed. You see, it is not only connecting to the enterprises down here, it is also connecting to ISP B, so that if this connection goes down, ISP A can forward the packet via ISP B. So what I'm trying to say is, wherever you got many autonomous systems and multi-homing, BGP will be there. BGP will be always there. Why BGP will be there? Because there will be policy in path selection. BGP will be always there. For example, this enterprises has got A to connect to the customer ISP B to connect to the customer. Now, when you have multiple connections, you will write a policy saying, this is a primary path, this is a backup path. See, that is policy. That is policy in path selection. Now, to achieve this policy in path selection, we use BGP and the attribute of BGP. That is why we have BGP between the borders. That's why the name of the protocol is also Border Gateway Protocol. BGP, Border Gateway Protocol. BGP, Border Gateway Protocol. Because in the borders only, you will have some policy-based path to be selected. Only in the borders, if you try crossing the borders of your country, there only they will ask you visa and all. Within the country, they don't ask you visa. They don't ask passport, they don't ask visa within the country. Only when you cross the border, there is a strict verification, strict identity check. Likewise, between the borders, you will have strict. So without policy in the internet, you cannot have a desired path selection. So to have a desired path selection, we write policy. When you write policy, there should be a protocol which can understand your policy. BGP is the one which can understand the policy easily. Using the attribute, you can make BGP understand what you want compared to the other routing protocols. Fine. Now, BGP is a multi-homing. BGP is used mostly in multi-homing scenario. Just now I showed you what is multi-homing. Connecting to more than one upstream ISP. More than one upstream. You know what is upstream? Upstream.
ISPs.
The autonomous system on top is a upstream. It can be ISP, it can be another customer, or it depends. Whatever the other autonomous system. See, this is 65,000. This is 655,000. Then this is upstream, and this is for this one, this is downstream. This is downstream. For this is upstream. So whenever you have one autonomous system connecting to more than one upstream, we call it as multi-homing. Multi-homing. Now, what is dual homing? There is another word called dual homing that is also used in the real world. Dual homing is this. You have two connections with the same upstream. This is dual homing connection. Whereas when you connect to different ISP, different autonomous system, this is 65250, this is 65000. Totally two different autonomous. This is multi-homing. See, BGP is used both in dual homing scenario as well as in multi-homing scenario. Now, why do we need a multi-homing? What is multi-homing? Connecting to two or more ISP to increase reliability. What is reliability? Always connected. Even if one ISP connection to one ISP fails, you will still have internet access. Secondly, performance. Whenever you got multiple paths, you select one path as the primary path, and if that primary path goes down, immediately it picks the backup path, that is reliability. Now, when you got multiple paths, you are choosing one primary, no? Why you choose that one as a primary? Because that has got better reachability, better metric than the other. In short, what I want to say is, whenever you have multi-homing, you can choose one, the best, and ignore the other. You can choose the one, the best, and ignore the other. That improves the performance, right? The best for a destination. See, for example, if there is some customer here, alpha, and some customer here, beta. Now, from your autonomous system, going to alpha, which is best, ISP A or ISP B?
So A,
Hmm?
alpha.
Correct. Yeah. What is the question? To reach alpha, which one is best, ISP A or ISP B? To reach alpha, this is you. Which one is best for you? Going by ISP A or B?
ISP A.
So what you said is right. Going by ISP A is better. That is how it is called as performance. For some customer, one ISP will be better. For other customers, another ISP will be better. That's called performance-based path selection. So the advantage of having multi-homing is reliability and performance. Do you have any question?
No, sir, so far clear.
Now, whenever you got dual homing, there are many options in learning routes from ISP. See, the first option is this. This is your enterprises. ISP A and ISP B both are giving you only default route. They're advertising only default route. They're not advertising all thousands of routes from their routing table. Rather, they give you only default route. This is one option. What is the advantage of this option? Your routers need not to process too many routes. Only default route you have. Your routing table will not be too big. Your routing table of your enterprises will have routes of local network and then a default network, default route. That's it. Nothing more. The second option is the routing table will have some important routes from the ISP. For example, they give you only 10,000 routes. But there are millions of routes in the internet. For those, we have a default route. So having both default route and partial route from the ISP is another option. What is the advantage? Your routers will learn only the important routes from the ISP. The rest of the routes are managed. Rest of the destinations are managed using default route. Okay, so we got default route and the precise route. For some destination, precise route. For the rest, default route. Next, the third option is learning the complete routing table, full route from the ISP. See, if you want to learn the full route from your ISP, you need to have a very big routers like ISP, Catalyst, devices, very big devices, costly device. If yes, then you may have this option. Otherwise, no. If you have a normal enterprises router, and when you learn millions of route from ISP, then your router will hang, will not be able to process those millions of routes. So if there is a very big router in your edge, and if you are willing to learn all the routes from the ISP, you can do so. So these are the options. When you have multi-homing, the first option is learning default route. The second option is learning few well-known destination routes, and for other, a default route. The third option is learning the whole routing table. Are you comfortable so far?
Yes, sir.
Next, Border Gateway Protocol BGP works between the autonomous system borders. For that, we should know what is autonomous system. What is an autonomous system? An autonomous system is a collection of networks under single technical administration. For example, this is Madhav and Co. Every router inside belongs to Madhav and Co. That's why I call it as autonomous system. This is different autonomous system. This is Aaron and Co. Madhav and Co. is one autonomous system. All these routers are working for Madhav and Co. All these routers are working for Aaron and Co. They are two different autonomous systems because there are two different administrations. This is one administration called Madhav and Co. This is another administration, that is another autonomous system. So a collection of networks under single technical administration is called as autonomous system. Is that clear?
Yes, sir. This is clear.
Now, if you take OSPF, RIP, EIGRP, all these protocols operate within Madhav and Co, within autonomous system. Whereas BGP operates between Madhav and Co and Aaron and Co. Two different autonomous systems. This is within, this is between. Right. Anyway, whether it is an IGP protocol or BGP protocol, they all have a loop-free guaranteed sharing of route info. How loop is prevented in RIP? Split horizon rule. And infinite metric 15. 16 is infinite metric. How EIGRP prevents loop? Dual algorithm. How OSPF prevents loop? Router ID. Likewise. BGP also prevents loop. How? Autonomous system number. If an update comes with an autonomous system number of my own, I will ignore it because it's my own update. That's how I can prevent loop. If I learn my own update from someone, then it will cause loop. In short, what I want to say here in the last line here, every routing protocol, including BGP, they all guarantee a loop-free routing information exchange. So far good?
Yes, sir. This is understood.
BGP is a path vector routing protocol. Path vector routing protocol. Why it is called as path vector routing protocol? Say RIP is a distance vector. Likewise, BGP is a path vector. In RIP, you will have only distance, hop count, and the direction. Here, not just the direction, it will also have a path. For example, this autonomous system, to go to this network, this is the path. It should go to 64520, and then it should go to 64600, and then it should go to 64700. So this is the path and this is the direction. See? BGP is a path vector routing protocol because it knows the path as well as the direction. It knows every autonomous system in the path till the destination. While advertising the routes from here, it will advertise with the autonomous system number. This will also advertise with the autonomous. This will also that is how this autonomous system routers know the path. The paths are informed while advertising the route. Path is one of the metric of BGP, one of the attribute of BGP, AS path. Okay. Now the difference between IGP and BGP is IGP, for example, OSPF. What OSPF advertises? Only the networks that are within the autonomous system, along with the metric you can see in the routing table. Whereas BGP advertises the path and the network with attributes. What is attributes? Metric. Attributes are similar to metric. I told you. Attribute is rich metric. All right. Any question?
Um, so for how many kind of homing is there? Like a dual
Only
homing,
two.
multi-homing?
No
Only
more
two
homing.
only. Okay.
Okay. Right. So now, last point you see.
Yep.
BGP allows administrator to define policies. So, the best reason the reason why BGP is best between the autonomous system is it allows you to tell what you expect while deciding the path. You tell BGP using the attributes how the packet should flow, what path your packet should take, which is nothing but the rules, which is nothing but a policy. BGP allows this flexibility, provides this flexibility of we defining the rules, policies. Now, BGP is an autonomous system by autonomous system routing protocol. BGP is an autonomous system by autonomous system routing protocol. Here, one autonomous system is one hop. See, if I want to go here, this is one hop, this is two hop, this is three hop, this is four hop. One hop is one autonomous system. Inside this you may have 1000 routers. Here you may have 20 routers. Here you may have 2000. That is not counted. Routers are not counted as a hop. Routers are not counted as a hop. One hop means one autonomous system. Doesn't matter how many routers are inside. Are you clear?
So could you repeat one more time? Router is not a count, but autonomous system is a countable, right?
Correct. For example, if it is a RIP, it will count the routers as one hop.
Correct, yes.
Here, even if you have 1000 router, 2000 router, 3000 router, how many hops? It's only 1, 2, 3 and 4 hop only. Even if you increase another 1000 router, will the hop count increase? No. Because one hop is one autonomous system only. It is not how many routers, it is how many autonomous system, how many groups. Yeah.
Okay. Even though I have a multiple ISP also, it will consider like autonomous system only.
Of course. Yes.
Okay.
Each ISP is an autonomous system. All right. So we'll see from here tomorrow. So far, I have given you a very important foundation. One is BGP is a autonomous system by autonomous system routing protocol. BGP uses TCP, which is secured way of forming neighbor. BGP provides reliability and improves performance. How? By multi-homing. Yeah. BGP has got rich metric called what?
Attributes.
Very good.